corporate finance practice problem using Excel. We'll be calculating the bond value, this time focusing in on changes in the maturity date and what the impact will then be on the bond value. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We're going to have our information on the left-hand side. We'll populate that information as we work through the problems in the right-hand side in the blue area. We're going to be calculating the value of the bonds, this time focusing in on changes in the maturity dates, the maturity in years, what is going to be the impact on the bond value as we vary those from 35, 12 to 8. So up top, we're going to have our information. The par value of the bond is going to be the 1,000. You can imagine that basically being determined by the bond itself. If you actually had a paper bond, you can kind of say, okay, there's par, the percent for the bond, 17. The yield market rate, this is the item not on the bond, what would be determined by the market or the market conditions, we're going to say 7%. And then the maturity dates are the ones that we're going to vary. We're going to start off with this one, which I will make green, 35. So 35 years. So we've done this calculation a couple different times, but now we're just focusing in on the new components, the varying factors, those being the maturity dates here. I'm going to also highlight the green item up top, which is the yield rate, which is typically the one that we're going to be using when we calculate our annuities that we're going to be doing in our present value of ones that we're going to be taking a look at. So same kind of thing we've seen in prior problems. We want to then calculate the two components of the value of the bonds, that being one, the value of the 1,000 at the end of the time period, and two, the annuity calculation, then adding those together to get the total value. Also noting with this particular problem, we have the par value of the bond or the percent on the bond being far higher than what is expected in the market. That then you can imagine us as the issuer of the bond as having kind of like the advantage in the sales price. So we'd be saying, hey, we're selling bonds out there. Our bonds pay 17%. You're not going to find that anywhere else. So, we're going to sell them for something higher than the par value. So we would expect then as we do this calculation for the amount that we get to for the price to be higher than the par value due to the rate being higher than the market rate. All right, let's do this. We're going to do the annuity first. We got the P times 1 minus 1 plus R to the negative N over R. And we're going to break that out into our table as we've seen in the past. We're going to be taking in the outside the P, which is going to be the 1,000 times the rate on the bond, which would be the 17%. That's going to give us our 170. That's the amount that we're going to get paid for the number of periods. In this case, paid yearly, 35 years. Starting point, 35 years. Now we're looking at the numerator of the formula, 1. And then we're looking at 1 plus R to the negative N. I'm going to pull that inside, 1. And then plus R, which is going to be the 7%, the market rate, not the rate on the bond. Then home tab and numbers, percentify, home tab, font, underline. Then we'll use the trusty sum function equals sum of these two items, percentifying that, home tab, numbers, percentify, taking that to the power of the number of periods, this being the thing that's going to be changing as we go through a couple problems. 35 to start off with, negative 35. Home tab, font, underline. We're going to pull this to the outside. This is going to be equal to the 107, shift 6, caret, in other words, negative 35, number of periods. Let's add some decimals so we can see activity happening. Numbers, decimals, stuff is happening now. Home tab, font, underline. Then we can subtract this out, getting to the end result in the numerator. 1 minus that thing we got to last time. And then home tab numbers, adding decimals. And then we're gonna go down to the denominator. This being R, market rate, not the rate on the bond, 7%. Home tab numbers, percentify, home tab, font, underlined. Bringing this into the outer column now. Taking that numerator, dividing it by the denominator. Adding a few decimals, home tab, numbers, decimalize, and then underline, home tab, font, underline. Finally, multiplying the outer column here, that being the 170 times that thing that we just got to. Let's add some pennies, home tab, numbers, pennies, 10 of them. We could replace the penny with a dime, 1 dime. Anyways, so now we're going to then do this another way. We can do it with the magic way, with a function over here. So let's do that. Annuity, negative present value, shift 9, rate. 7%, comma, number of periods, 35 of them, comma, payment 170. So there we have it again. We could break the annuity out to present value of 1 payments. So let's do that. That's good times. 1, 2, bringing this all the way down. Autofill, grabbing the autofill handle to autofill the 35 payments, centering it, home tab alignment, center. Payment's going to be the 170. There's going to be 35 of them. Present value in each one, negative PV, shift 9, rate 7%, comma, number of periods 1, because we're starting off with the first period, comma, comma, because it's not an annuity, but future value of 170. Value 159, no pennies. Payment's going to be the same each time, 170, because it's an annuity. That's like the definition of an annuity. Payment's the same every time. Present value, shift 9. Rate is going to be 7% again. 7%, comma, number of periods is going to be 2, comma, comma, future value 170. Prior value plus the current present value we present valued. I'm going to copy this down, 35 payments. Before we need to make a absolute reference of anything that's not currently in the table, that being the 7% outside here, double clicking. 7% is in E6, putting my cursor in E6, selecting F4 on the keyboard, $ before the E and 6, making it an absolute reference. You only need a mixed reference, but absolute is easy, and so that works too. Then we're going to select these 3, fill handle, dragging the fill handle down, dragging the fill handle down. We get once again to that 2202, 2201, I should say, there, because that would be the right thing to say. I'm trying to be correct. And then I'm going to take this. We could take this 1 period down again. I could say, let's take it down one more time. This is going to be 35, and let's just tack on that in payment, which is going to be the 1,000. And that'll give us basically our ending result right then, right there, at the 2295 rounded. There it is, right then, right there. I'm going to make that yellow. So that's one way we can kind of calculate it. We'll get there again doing the second format. So let's now use the tables. I'm going to use the tables. This is going to be equal to the payment of the 170. And then we'll pick up the proper table and annuity looking at 35 periods, 7%, 7 and 35. Annuity table, 7%, 35 on the periods is going to be down here. That's the 12.948, 12.948, 12.948, 12.948, 12.948, 12.948. Let's add a couple decimals. Home tab, numbers, couple decimals, multiplying out 170 times 12.948. And we get to that number again. Let's add 2 decimals here, so that we have it slightly different due to rounding on the tables. Now let's calculate the present value of the 1,000 using this formula. Present value equals future value times 1 over 1 plus r to the n, starting with the value of the end result of the bond, the 1,000 par value. Then we're going to have the 1, and then the rate is going to be 7% using the market rate again, which I'll greenify to make sure I pick up the right rate every time. Home tab, numbers, and percentify. Home tab, font, underline, adding with the trusty SUM, otherwise known as the sum function. Adding those up, making it a percent. Home tab, numbers, percentify. Number of periods now, we're looking 35. I'll make that green too, because that's where our focus is at. That's the thing that's going to change as we move forward. 35, and underline that one. And this is going to be equal to the 107 shift 6 caret to the power of, in other words, 35 years. Home tab, numbers, pennies, and decimals, and then home tab, numbers, and underline, and then we're going to take the numerator divided by the denominator. The num divided by the denom, and then home tab, numbers, and add a couple pennies. Okay, so if we add the whole thing up, then we have the annuity we got to last time, which added up to, and I'm going to get it from the present value formula, and then we had this time the 93.66. Adding those two up, total value then, or total price, we would assume $2,200. 294.77. Now, as we change the number of years, you would expect that then to go down. You expect basically the price, to decrease if you have everything else the same, but then number of years going down. We'll see that as we then go to 12 and then 8 in the future. But first, let's present value this one here. This equals the present value shift 9. We want the rate 7%, comma, periods, which is going to be 35, comma, and then comma again, and then the payment is the future value of 1,000 and enter. There it is again. Let's do it with the tables now. Tables, and that's going to be the 1,000. Picking up the proper table, that's going to be the present value of 1, 7%, 35 periods, 7%, 35 periods way down here. That's going to be the 0.0937, 0.0937, 0.0937, 0.0937. This equals the 1,000 times the 0.0937. And there we have it again, close, not exact, due to tables being rounded. Let's do it again. Now I'm going to go all the way to the left. I'm in column A. Then I'm going to scroll down where we're going to then move to the 12 years. Same stuff, except we're just changing from 35 to 12. I'll make that green. We're on option 2 this time, and we can see the change in the price as we do so. So same calculation. We're going to take the annuity, then the present value of the 1,000, but this time periods 12. So P times 1 minus 1 plus R to the negative N over R. Same calculation over here, annuity, but 12 periods this time, which is going to start off with the 1,000 times the rate that would be on the bond, the 17%. From here on, we're basically using the market rate, the rate that wouldn't be on the actual bond if you had an actual bond. This is going to be 1, and then 1 plus R to the negative N, so 1 rate, still 7%, making it a percent, home tab numbers, percentify, underline, trusty sum it is those two. Then we're going to home tab numbers, percentify to the power of now 12. Here's where the difference happens, negative 12. That's the number of periods. That's what's changed. And then we'll underline that. And then this is going to then give us to the outer column equal the 107% shift 6 caret. In other words, periods 12, adding some percents or decimals. Home tab numbers, decimalizing it. Home tab font, underlining it. And then subtracting the 1 minus that thing we just got to, adding decimals, home tab number, adding decimals again. That's the numerator. Denominator is going to be the rate being the 7%, 7%, percentifying, home tab numbers, percentifying, underlining. We'll bring this out to the outer column, taking that numerator divided by that denominator, the num divided by the denom, and then home tab, font, underline, add some decimals, number, decimalize, and then multiplying the outer column, 170 times that thing we just got to, adding pennies, home tab numbers, and then we've got 26 on the cent. That makes sense. It makes 26 cents. Okay, so now we're going to then say that we have over here, we'll do this magically with a formula, negative present value, shift 9. The rate, we're going to be picking the 7%, comma. Number of periods is going to be 12. 12 now, comma. And then the payment is going to be the 170. So there we have it, done it again. Let's break the annuity down into a series of present values by saying 1, 2. Adding those up, we're auto-filling them down. We're not going to add them up, we're going to auto-fill them down to 12 periods. That's what we need. And then home tab numbers and center payment is going to be equal to the 170. Then we're going to present value each one of them equals PV shift 9. Rate is going to be the 7%, comma, periods 1, comma, future value 170. That's the value for that first payment. Second payment will be the same. Why? Because it's an annuity, and that's like the definition of an annuity. So present value shift 9. Rate, once again, 7%. I'm going to go ahead and absolutize this as I go now. F4, $ before the E and 82, because I'm going to copy it down. So I'm just thinking ahead here. My mind is thinking ahead like 10 steps as if I'm playing chess game. And this is going to be the number of periods, which is 2, comma, future value 170. Then I'm going to add the prior one plus the current one. And then we'll autofill that down, selecting these three, grabbing that fill handle, and then dragging fill's handle down. There we go. Then we'll add one more. We could add one more and say there's the same number again, except it's not rounded here, or it is rounded there. It wasn't rounded before because we had cents was made last time, 26 cents. And I could do this one more time and then say that we have the amount of 1,000 to get us to basically the answer, which would be that 1794 with no cents. It still makes sense, but it doesn't have cents in the sense of pennies. And then we'll make that yellow. So there's that. So then we'll do this one again. We'll do this with the table now. Let's do it with the table time. Time for the table, table time. That's going to be the 170, picking up the proper amount from the table. And we're now at the 7 and 12. 7 and 12, so there's the 7. There's the 12, 7.9427. 7.9427, 7.9427, 7.9427, 7.9427. Multiplying the 170 times the 7.9427, we get to the same result once again. All right, second half of the problem, present value of the 1,000. So now I'm looking 1,000 present valuing, where I'm going to make this rate the green one because that's the one we use most, and 12 years. I'm going to greenify those two. So formula PV equals future value times 1 over 1 plus r to the n, breaking that out into our table again. This equals the 1,000. 1 plus r to the n is going to be 1 plus r, 7%. Home tab numbers, percentify, underline, to the n, which is going to be 12 years, 12 periods in years in our case. Actually, first I need to sum this up. Hold on a second. Equals the sum of these two. That's going to be then percentified at the 107, then to the n, then to the n. We got the 12, underline, home tab font, underline, bringing this into the outer section now. 107%, shift 6, caret, 12, adding decimals, home tab numbers, decimalized. And then home tab, font, and underline. And then we could take then the num divided by the denom, the num divided by the denom, and then home tab numbers, add a couple decimals, and we get 1 penny. 1 penny has been added, which is important. Don't forget the penny. If I add that to the present value we got last time, the 135026 pennies, adding that up, the 44401 plus the 13550, we get the 1794.27. That then should match, in essence, what we got over here, even though we had no cents. It made sense, but had no sense at the same time. And then over here, we had it, and this one makes sense and has sense. So, there. And then we'll do this again. We could do this again. This would be the negative present value, shift 9 rate. It's going to be the 7%, comma, number of periods is going to be the 12 number of periods, comma, comma, chameleon, and then 1,000. So there we have it again, 44401. Let's do it one more time with the tables before we move on to the next one. This is going to be then the 1,000 amount from the tables, making sure we got the proper table, present value of 1. We have the 12 periods, 7%, 7 and 12, 7, 12. 0.4440. That's easy to remember. I don't even have to say it like 100 times like normal. 0.4440. 444. So there we have that. Looks good. We're missing the penny on that one though, but that's okay. That's because of rounding. So we have here the 1794.27, which of course is different from what we got up top last time, which was the 2294, because this one would be paying us for a much longer time than the second option. Now let's go all the way to the right and let's do it one more time. And so this time I'm all the way in column A. I'm going to scroll down to the rows now, row 136, where we're now going to be focusing in on 8 periods. We're going to change the date, the end date again. This time 8. We're on 8. And then I'll make the one that's the market rate green, because that's the one we'll use most often. Calculating it again, annuity portion, P times 1 minus 1 plus R to the negative N over R. I'm going to pull this out to the outer column. It's going to be the 1,000 times the 17%. And then we've got the 1 plus R, 1. I'm bringing the 1 plus R in the inner column. 1, rate, 7%, market rate this time. Home tab, numbers, percentify, underline, home tab, font. Summing it up, trusty sum function equals SUM, shift 9, up arrow, holding down shift, picking up those two. That needs to be a percent, home tab, numbers, percentify, to the number of periods, negative periods, this time 8. Let's put an underline there, home tab, font, underline, bringing this to the outer column, taking that 107, shift 6, caret then to the power of negative 8. That needs decimals, home tab, numbers, decimalize. Then we'll underline it, home tab, font, underline it. Then we'll subtract this out, having then ending at the full numerator having been calculated. 1 minus that thing we got to. That needs decimals, home tab, numbers, decimalizing it. That's the num, otherwise known as the numerator. The denom, otherwise known as the denominator, is R, or 7%, which needs percentification. Numbers group, percentifying, underlining. Taking this out to the outer column so we can take the num divided by the denom, and that'll give us 6. Needs some decimals, home tab, numbers, decimalizing it. And then home tab, font, underline, multiplying the outer column, this time that being the 170 times that thing we just got to. I'd like to see some pennies, a few cents on it. Could I make some cents? There's some cents, 12 of them. There we have it. So now let's do it again, this time with the formula, the magic way. So we're going to go over here. This is going to be negative present value, shift 9, rate 7%, comma, number of periods, now 8 this time, which is green, making it easy to pick up. Payment 170. So there we have it again. And enter. So it has gotten to that same number again. Let's break this down into a series of present value 1 payments. 1, 2, selecting those, grabbing that handle, Phil's handle, and dragging Phil's handle down. And then home tab, numbers, and center. And then the payment's going to be 170 per period. We'll bring this back 1 period at a time, 1 at a time. That's how we'll do it. Just 1 at a time. PV, shift 9, rate is going to be 7%, comma, number of periods 1, comma, comma, future value 170. There we pulled that one back 1 at a time. We're on period 2. That's where our focus is. Period 2 here. Negative PV, shift 9, rate 7%. I'm going to percentify that as we go. F4, $ before the E and 139, comma, number of periods 2, comma, comma, chameleon, and then 170 and enter. Then we'll add the prior amount plus the current amount. We'll select those 3 items, put our cursor on the autofill handle, and drag that handle down to 8 payments. There we have our end result, same, except it doesn't have any cents, even though cents has still been made. Cents has still been made, even though no cents is there. And then we'll make that 8 again. Now note, you can then take the amount of 1,000, and that'll get to our end result here with just that format. So I'm going to go home tab, font, and make that yellow. So we could do that. That's one way we can get there. By there, I mean to the destination of the answer of like the value or price. Then let's do the table. Tables over here, 170. Picking up the table, making sure we have the proper table. This is the annuity table, looking 7%, 8 periods, 7%, 8 periods, 5.9713, 5.9713, 5.9713, 5.9713, multiplying the 170 times the 5.9713 gets us once again to the 1,015.12. Let's do the present value of the 1,000 portion now. That's going to be the present value of one formula, PV equals future value times 1 over 1 plus R to the N. Breaking that out in our table, we start off with the 1,000, which is the future value. And then we have the 1, and then the rate which is 7% market rate, not the rate on the bond. I'm going to make that green so I don't mess that up. Greenify the 8 down there because that's where our focus is at as well. We need a rate or percents here so we can see some stuff happening. Home tab, font, underline, trusty sum equals SUM, shift 9, up arrow once, up arrow again with the shift down, adding a percentify, home tab, numbers, making it a percent to the power of n. That's going to be 8 this time, number of periods. We'll bring this into the outer column, taking that 107% to the power of shift 6, caret 8. And then I'm going to put an underline there and then add some decimals here. Home tab, numbers, decimalized. And then underline. And then I'm going to take this is going to be the num divided by the denom. The num divided by the denom, adding some decimals, home tab, numbers, couple pennies. 1 penny once again, 1 penny. 582 and a penny. So we're going to pick up what we got last time. Present value of the annuity. I'll pick it up from the Excel formula, and then that adding to what we got this time, that's the 1597. So once again, that number's different. You can kind of compare what's happening to the prior amount that we had when we had 12 periods. It was at 1794.24, 27 cents. And then now it's at 1597.13. So it's going down because, again, obviously we have less payments. We had 12 payments last time, and now we have 8 payments that are going to be going out into the future, and so on. So there's a little, it can be a little bit, obviously the payments that are further out into the future have less value to them, but you're going to have more payments basically out into the future. As you have a longer rate here, as we increase like 35 compared to 8, that also means that the principal portion is going to be less. So you're going to have more payments, more annuity payments. That principal portion of the bond is going to be less at the end. As the maturity gets smaller, the principal amount of the bond here is going to be worth more because it's closer to the end result, and the annuity payments are going to be less because there's less of them, those annuity payments that are going to be made as you go. So it's a little bit more complicated than you would think, as the price changes because of those factors involved. But now let's go ahead and say present value here equals PV, shift 9. We're picking up the rate 7%, comma. The number of periods is going to be now 8 periods, comma, and now comma, comma, because now future value 1000. So there it is again. And now let's do it one more time with the table. We're doing it this time with the table. And that's going to be 7% and 8. So 7 and 8. 7 and 8. 0.5820, 0.5820, 0.5820, 0.5820 equals 1000 times 0.5820. We got the 182 and no penny because it's rounded. The table's rounded to 4 digits.